Welcome to my channel. This video is about translating variation statements into mathematical equations. Let's review about the different types of variation. So I have here direct variation, y is equal to k times x, where k is the constant of variation, x is the independent variable and y is the dependent variable because the value of y will depend on the value of x. In inverse variation, we have y is equal to k over x. So the constant k here is in the numerator and the variable, which is the independent variable, is in the denominator. Okay, so let's have direct variation statement. So y varies directly with x. So means s is equal to k times x. If I have y varies directly with the square of x, means y is equal to k times x squared because this is square of x. Now for inverse variation, y varies inversely with r, means y is equal to k over r. So the other variable should be here. And we have here q varies inversely with the square of r, which means q is equal to k over r squared. Now for joint variation, we have y is equal to k times x times z. So we have here three variables. So the value of y will depend now on the value of x and z. And k again is the constant of variation. K should not be equal to 0 in all of this. Now for combined variation, it depends if what kind of variation you are going to combine. It can be direct and inverse or joint and inverse. So in this example, I have here the combination of direct variation and inverse variation, which means that y is equal to kx over z. Okay, so let's have the variation statements for this type. So y varies jointly with x and z. Of course, that is y is equal to kxz. Or p varies jointly with r and s. Simply, p is equal to k times r times s. Just multiply the other two quantities, r and s. For the combined variation, I have here y varies directly with x and inversely with z. So that is now y is equal to kx over inversely with z means over z. And now another one. Q varies jointly with s and the square of r. Okay? And inversely with t. First, we need to do this one. Q varies jointly with s and the square of r. So jointly, it means all of this variable should be in the numerator. So we have q is equal to k, that is the constant of variation, times s and times r squared. This is from up to here. And inversely with t. Inversely means should be in the denominator, so divided by t. Okay, that's how you're going to write. Now we're going to translate variation statements to mathematical equations, and we are going to have some real life problems. So the variation statements there, and on the other side, the mathematical equations. So let's have number one. The amount of gasoline needed by the car varies directly with the distance it covers. First, you need to identify the two quantities here, or the quantities. It can be two or more. So we have here the amount of gasoline, and we have the distance, which means it involves two quantities. So if it is only two quantities, so it's either direct variation or inverse variation. Now, next is to find out the type of variation. Since we have here varies directly, it means direct variation. So simply, we can now write G is equal to K times D. So it means that the amount of gasoline needed will depend on the distance that you are going to cover. More distance, more gasoline. Next, the time T to finish a project varies inversely with the number of people working on the project. So again, let's identify how many quantities here. We have the time and the number of people working. So again, there are two quantities here. And the type of variation varies inversely, which means inverse variation. Okay? So it means that the variable p is in the denominator. So t is equal to k over p. Okay, that's very easy, right? Now, makes sense because if there are more people working on the project, of course, you're gonna finish or less time needed to finish. Okay, the area A of a parallelogram varies jointly with the base and the height. So look at this one. So we have here A, we have the base B, and we have the height here. So there are three variables here or three quantities here, which means it's either joint variation or combined variation. But here varies jointly, which means joint variation. So that is simply A is equal to K times B times H. So let's have another example here. The cost of electricity, C, is directly proportional to the number of appliances, A, in the house. So direct proportion, so C is equal to K times A. Yes, of course, the higher if you have a lot of appliances, the cost of electricity is higher also. Now, the savings S is inversely proportional to expenditures. So we have two quantities here, savings and expenditures, and this is inversely proportional. Proportional means inverse variation. So S is equal to K over E. And the expenditures, E, is directly proportional to the number of family members. So directly proportional means direct variation, that is E is equal to K times F. Okay, another one. Y varies jointly with the cube of x and the square of z. So this is jointly. So simply y is equal to k times the cube of x, and that is x cubed, and the square of z, and that is z squared. Y varies directly with the square root of s and inversely with the cube of r. Now, y varies directly with the square root of s. Let's stop there. So let's write that first because this is combined variation, which means y is equal to k times the square root of s. And inversely with the cube of r means divided by r cube. Okay? So now, let's do the opposite now. We are given the mathematical equations and you can write the variation statements or just mention or state the variation statements. Okay, number one, A is equal to K times B. What kind of variation is this first? This is direct variation. So we can say that A varies directly as B, or A is directly proportional to B. You can say it that way. Okay, you can pause the video if you want to answer it first, if you want to do it yourself. And pause if you are ready. Okay, here we have M is equal to K over N. So what kind of variation is that? The other variable is here, which means it is inverse variation. How are we going to say the variation statement for inverse? That is, M varies inversely as N. Okay, we have here P is equal to K times Q times R. So it involves three variables now, or three quantities, which means this is now joint variation. So how are we going to say joint variation? The joint variation statement, that is, P varies jointly as Q and R. Okay, what about this one? T is equal to Ks. What kind of variation is this? This is direct variation. So you can say that as A or T varies directly as S. Okay? Now, we have here T is equal to K times S over W. For the first one, up to K times S, this is direct variation. And divided by W, that is inverse, which means this is now combined variation. So that is T varies directly with S and inversely with W. Okay? T, this Ks means that varies directly with S and inversely with W, divided by W. And what about if I have A is equal to K times S squared? So this is still two variables, which means direct variation. If it is two variables, sorry, your choices would be direct variation and inverse variation. Now, inverse variation, you know that the other variable should be in the denominator. So this one is direct variation. So A is equal to K. S squared means A varies directly as the square of S. Or you can say that A is directly proportional to the square of S. Okay, so that's all for today, and thank you for watching, and see you on the next one. Please don't forget to subscribe to my channel for you to be updated on my incoming videos. Bye!